Section 1.3, Solving Equations. To simplify, evaluate expressions involving positive and negative exponents, roots, and or absolute value, and to write and or solve and apply linear equations. Solution of an equation. A solution of an equation is a number or numbers that makes the equation true. Here's a chart for properties of equality. You will find this chart in the resources on our group page. Here we have the reflexive property. This is when the left side equals the right side. It is a mirror image of itself. A symmetric property has two quantities. If A equals B, then B also equals A. Transitive property has three possible outcomes. If A equals B and B equals C, then A has to equal C. Addition property. If I already have that A and B are equal, then if I add the same quantity to the left and right side of the equal sign, then that left and right side should remain equal. Subtraction property. If I have two quantities that are also equal on the left and right side of the equal sign, and I subtract the same amount from both of those quantities, then the left and right side of that equation will remain equal. Multiplication property, the same as the two above, except I'm going to multiply on the left and right side by the same quantity, then the left and right side of the equal sign will remain equal. The same with division. As long as I don't divide by 0, which would make the problem undefined, then I would have the left and right side equal as long as I divide by the same quantity on both sides. Substitution property, if A and B are equal, then B may be substituted for A in any expression to obtain an equivalent expression. This is the procedure you need to use to solve equations. 1. Copy the equation from the book. 2. Simplify by distributive property and combining like terms. 3. Get the variables on the same side and the constants on the opposite side of the equation by using inverse operation. Usually that will be addition and subtraction. Number 4. We want the coefficients to be a positive 1, and we want to do that by inverse operation, typically by multiplying and dividing. Example 1. 8x plus 2 equals 3x minus 13. Let's get our variables on the same side. I'm going to move my 3x to the left side by subtracting 3x on both sides. This is inverse operation by subtraction. Combine like terms, I get 5x plus 2 equals a negative 13. Then I want to get my constants on the opposite side of the variable, so I'll subtract 2 on both sides by inverse operation. That leaves me 5x equal to a negative 15. Divide by 5 on both sides by inverse operation of division. That will get my coefficient to equal a positive 1x, and my solution is a negative 3. Example 2. A negative 3 times the quantity of 2x plus 4 equals a negative 2x plus 4. We want to copy that problem. Then we want to simplify by distributive property. That gives me a negative 6x minus 12 equals a negative 2x plus 4. Get the variables on the same side. Again, I'm going to move my 2x over to the left by adding 2x since it's negative. That's inverse operation. That's going to give me a negative 4x minus 12 equals 4. Let's eliminate the constant on the left side by adding by 12 on both sides. That gives me a negative 4x equals 16. Divide by a negative 4 on both sides. And my solution is x equals a negative 4. Example 3. Here we want to copy the problem, then simplify by the distributive property. That gives me 10x plus 5 equals 0. My variables are already on the left side of my equation. All I need to do is eliminate the constant by subtracting by 5 on both sides of the equal sign. That gives me 10x equals a negative 5. Divide by 10 on both sides. That gives me x equal to, when I simplify, a negative 1/2. Example 4. Again, copy the problem. Then we're going to use the distributive property. I'm going to bring down my 6. This is a negative 1, which I will distribute through, which gives me a negative 4w plus 6 equals a negative 12. Let's simplify by combining like terms on the left side. That gives me a negative 4w plus 12 equals a negative 12. Eliminating my constant on the left side, I'll subtract 12. That's inverse operation. That gives me a negative 4w equals a negative 24. Divide by a negative 4. And w will equal a positive 6. Example 5. Let's copy the problem, then simplify by the distributive property. A negative 4 distribute by a negative 2 gives me a negative 2w minus 6 equals, bring down the 3, distribute the negative 3. That gives me a negative 6w plus 3. Combine like terms on both sides, gives me a negative 2w minus 10 on the left side of the equal sign, and on the right, a negative 6w plus 6. Let's move the w's to the left side by adding 6w on both sides. That gives me a 4w on the left minus 10 equals 6. Eliminating the constant on the left by inverse operation, add in 10 on both sides, gives me 4w equals 16. Divide by 4 on both sides, inverse operation of division, gives me w equal to 4. Here we want to solve each formula for the indicated variable. We want to treat each letter, which is a variable, the same as an actual number. So what I want to do is let a be my true variable I'm solving for in this problem. I want to let f and m represent a number in a sense. So m is my constant. If it was a 3a, I would know I would divide both sides by 3. I will do the same, but instead of by 3, I'll divide by m on both sides. That gives me a solution. The m divided by m cancels out to 1, which gives me a positive coefficient of 1, leaving me just a. And my solution on the left is f over m. On number 2, we're going to copy the problem, and they want me to solve for b. So in this situation, what I want to do is to really eliminate my denominator of 2. So what I will do is multiply both sides by 2. When I do that on the left, that'll give me a 2a, here a capital A, and 1/2 times the 2 will simplify to be just a positive 1, leaving me b times h. I'm solving for b, so I'm going to let h represent basically a real number. If it was a 5b, I would divide by 5 on both sides. But this is a variable, so I'll just divide by h on both sides. And when I do that, my solution is going to be 2a over h equals b. Example 3. Again, copy the problem. I want to solve for h. Here, I have pi r squared plus 2 pi rh. This would be similar to like 18 plus 2 pi rh. In other words, this is just a number. So what I want to do is subtract that number by inverse operation. So we'll just subtract pi r squared on both sides of the equation. These aren't like terms, but we can still write the expression s minus pi r squared. And on the right side, we're left with 2 pi rh. I'm solving for h, so I will let pi and r just represent real numbers. And when I do that, I can just divide by 2 pi r on both sides. On the right side, all my terms will cancel out, leaving me with h, which is what I want to solve for. And on the left side, s minus pi r squared over 2 pi r. Example 4, a equals 1/3 h, a sub 1 plus a sub 2, we're solving for a sub 1. These are not like terms, even though they're both a's. Remember, even the exponents and the subscripts have to be exactly the same for them to be like terms. We could distribute and then eliminate the terms that we don't want, such as the ones that aren't a sub 1, and then divide or multiply to get my coefficient to be a positive 1. But the easiest way to do this is to go right at the problem and multiply both sides by 3. That'll eliminate my fraction. That will give me 3a equals 1/3 times 3 will simplify to be a positive, leaving me h times a sub 1 plus a sub 2. Then I can divide by h on both sides, giving me 3a over h. Here, the h's divide out, leaving me a sub 1 plus a sub 2. Now I'm solving for a sub 1. All I need to do is subtract a sub 2 on both sides. So my solution would be a sub 1 equals 3a over h minus a sub 2.